Okay, let's talk about some properties of logarithms. Let's start off with the first property here I'm going to give you. It says that log base a of 1 is equal to 0. Now you can check this. This means log of any base, right? If you plug 1 in, you're going to get 0. And check by doing the loop. Remember, a to the 0, no matter what a is always going to be 1. So if you plug 1 into a log, your answer is 0. The next property, log base a of a is equal to 1. Now you can check here by doing the loop also. A to the 1 is equal to just a, right? A is equal to a. The next property, log base a of a to the x is equal to x. Now check by doing the loop here. It's saying a raised to the x is equal to, of course, a to the x. So that verifies too. So those are three basic properties that we have. You plug 1 in, you get 0. If you plug the same number as the base in, you get 1. And if you take the same base and you raise it to some power, your answer is going to be just whatever the power is. Let me give you a few examples of each of these next to them. So if someone said, what's natural log of 1? You say 0, because when I plug 1 into any log, I get 0. If I say, what's log of 10? Well, remember, because if you don't write a base, it's automatically implied to be 10, then I'm saying log base 10 of 10 is equal to what? 1. According to this, 10 would be equal to 1. Here, let's say we did log base 4 of 4 to the third. The answer is just 3, because same base here, and then here's your power, so your power is your answer. Okay, those are some general properties. Now let's move on to another property of logs. I'll call this property 4. It's the product property. So let's say I have a log, and inside I have a product, and I'm going to say x times y. So you have one log, and inside it you have two things being multiplied. Well, this property says that this is the same as log base a of x plus log base a of y. So what this property allows you to do is take a single log, okay, that has two things being multiplied inside of it, and you can take that single log and it will split up into two logs. It'll be addition between them. Notice the base here is the same. Also, you can look at this property the other way. If you have two logs with the same base and two things here being added together, you can condense them down into that. Okay, let me give you an example of this. Let's do log base 3 of 9x. Okay, well, because 9 is being multiplied times x, we can say that this is log base 3 of 9, okay, plus log base 3 of x. Now, log base 3 of x, we can't really figure out what that is, but log base 3 of 9, we can. Remember, you'd say, okay, 3 raised to what power is 9? Well, 2. So this is actually just 2 plus log base 3 of x, and that's it. Let me give you another example of using this property. Try something a little more challenging. Let's do 27xy. Okay, now you have multiplication, but you actually have multiplication between three things. So just as you thought, if two things split up to be 2, then three things are going to split up to be 3. So you've got log base 3 of 27 plus log base 3 of x plus log base 3 of y. Now these last two you can't do anything with, but you can say here 3 to what power is 27? Well, the answer is 3. So you just get 3 plus log base 3 of x plus log base 3 of y. Now the process of going and taking a single log and breaking it up into more logs is known as expanding a logarithmic expression. So what we're doing here is expanding. Now what I'd like to do is I'd like to show you the same property, but I'd like us to work backwards. I'd like us to start with two logs. So I'm going to have, let's say, log of x plus log of y. Log of y. And what's that equal to? Okay, well, notice there's no base here. but it's implied that the base is 10. So there's actually a 10 down there and 10 down there. Since they have the same base, we can condense these down into a single log. This time it'll become xy. And that's just using this property, but backwards. Let me do another one. Let's do log base 2 of x plus log base 2 of 4 plus log base 2 of z. Okay, I have 3 log expressions. I'm going to condense them down into one. So notice that addition becomes multiplication. So I'm going to take this, this, and this and multiply them together. So I get x times 4 times z, that's just 4xz. And now it's all inside of one log. Okay, now let's move on to our next property. Our next property has to do with, instead of multiplication, division. So we saw that multiplication became addition. Division is going to become subtraction. So if you have log base a of x divided by y, it'll become log base a of x minus log base a of y. The x goes first, then the denominator here, y, goes next. Here's an example. Let's go ahead and break this into two pieces. What's log base 2 of z over 4? Okay, this is equal to, because there's division, I can split it into 2 logs. I'll have subtraction between them. And what goes first? The z. The other one, 4. Now, this is just log base 2 of z. We can't do anything with that. But here we can say 2 to what power gives us 4? Well, of course, 2 squared. So that log just becomes 2. Okay, let's do another one. For another one, let's do log base 7 of 49x over t. Okay, be careful here. We have division, but notice in the numerator we have multiplication. So first thing I'm going to do is just use the fact that this division can break up to become two things. 49x is my top, minus log base 7 of the bottom, which is just t. Okay, now this is multiplication. And remember, multiplication becomes addition. So this will become log base 7 of 49 plus log base 7 of x. And we still had over here minus log base 7 of t. And log base 7 of 49 means 7 to what power is 49? Well, that just means 2. And then plus those logs that we still have sitting there. Log base 7 of x minus log base 7 of t. And that would be it. Now, let me give you another problem. This time, instead of expanding everything, I want to condense. So let's try and condense here. I'll give you a log, or let's do natural log of t minus natural log of z plus natural log of m. Okay, let's condense this into one thing. Well, first of all, you have to make sure you have the same log. So it's same logs, right? Same base. Remember, the base here is e. So what I'm going to do is move from left to right. I'm going to put these two together first. Remember, 2 logs with subtraction between them becomes division, right? Then I still have plus natural log of m here. So all I did was put those two together. Now this is equal to, now addition becomes multiplication. So these 2 logs will condense down to be a single log. I'll have multiplication. I'll have this times this. So that's t over z times m, which is the same as m over 1. So it just becomes tm over z. And that's it. We have condensed these 3 logs down into one. All right, let's move on to our last property. It's probably one of the more important properties of logs, the 5th one. It says that log base a of x to the n equals n log base a of x. So essentially what this property is saying is that if you have a log, you have something raised to a power, the power can be pulled out in front and be multiplied like a number. So here's an example. What's log base 3 of x to the 5th power? Okay, well that's equal to, according to this property, 5 log base 3 of x, and that's it. Okay, we can do another one. How about this? What's natural log of the square root of x? Okay, this one's a little tricky, but what we're going to do is we're going to say, okay, this is natural log. Now square root means x to the 1/2, right? 1/2 power means square root. Now we can pull the 1/2 out in front. And the 1/2 comes out, and you're just left with natural log of x. So you can see that property being used where we pull the power out. Now, what if someone wanted you to go the other way, and they wanted you to, instead of pull the power out, start with the number in front and use the property backwards? Let me do that. What if we have 1/5 log base 2 of z? Okay, what we could do, we could take the 1/5 and we could put it up on the z. So this would become log base 2 of z to the 1/5. And then you could write that as log base 2 of the 5th root of z. Okay? I'll do one more. If we have, let's say 7 log of m, this is the same as log m to the 7th. Remember, the 7 comes up and becomes the power. There is no base here on the log, but remember, that means it's 10. So that's the 5th property. And the next examples, what I'm going to do is I'm going to be working with all of these properties together. We're going to start with something, we're going to be asked to expand it out, or we're going to start with a big old thing, we're going to be asked to condense it down.